how do you find the sine value, or what angle has the sine of negative, or excuse me, positive root 3 over 2? What would you do? All right. Going the long form because people know what they're doing. I plot them through. I figure out what triangle. I know I'm positive, so I'm up here. Which angle has a sine value where it's root 3 over 2? Well, that's your 60. Okay? So the angle that has the root 3 over 2 is your 60-degree angle. But in terms of radians, it is pi over 3. Okay? Today, I want us to make sure that you give me answers in solely radians. Okay? You're obviously using your 30/60s or your 45s to find the triangle, but when you write down what the answer is, just leave it in radians for right now. Okay? Tangent -1. Same basic principle. When we worry about tangent, we're going between here, pi over 2 and negative pi over 2, excluding them. What triangle is going to give you a -1 for a tangent value? It's the 45, so it's the negative. So it's 1, -1, so it's our 45. So in terms of radian degree then, what would the radian value be for negative pi over 4? Okay? Nothing crazy. So let's take it to the next level.
Well, so we went to be on this one.
No. We're using the same principle idea. Oh, we just did these.
Whoa.
What I want to do today is I want to talk about solutions. Yeah. Within, let's say all solutions within one revolution. I want to find all possible solutions to this equation that are within one revolution. I believe that's how they write it, one revolution. Let's double check. Oh. It's from 0, including 0, through 2 pi, so it's not a including 2. Okay. So what I'm doing here is I'm going to find all angles within one revolution of the circle that makes this equation work. So here's what we have. 2 sine of x minus 1 equals 0. And I'm going to ask, what do? You got to solve for x. What do you do?
Add 1.
And then,
Divide by 2.
so I have the sine value of x is 1/2. Then I inverse it. Exactly. And now what we're doing here is saying that x is going to equal the inverse sine value of 1/2. Okay? What we're doing is we're working our way into what something looked like in section 13.4. So what triangles give you sine values of 1/2? 30/60. Now, so it's a 30, so it's 1 and 2. It's first quadrant, so it's 30 degrees. What is that in terms of radians? Pi over 6. Now, where else is sine value positive? Second quadrant. Second quadrant, y is positive because it's over here. What is the value here? Perfect. So those are your angles. The angles that have the sine value of 1/2 within one revolution, pi over 6, pi over 6. And that's it. Not bad, is it? The only difference between this and what we've been doing is that we're asking for all angles within one revolution, whereas what we were doing before, it's within that specific parameter, between that positive, negative degree value. Here, we're actually going to use that reference angle and bounce them through. Jeez, it would take tests faster.
You showed up
Yeah,
late.
he showed up, yeah, he showed up.
Oh.
You think you were going to get out of it?
What?
Did you show up late on purpose? No.
Okay. Same idea. I want to solve for x. I want to find all possible values of x within one revolution. 4 times the cosine of x plus 1 equals negative 1.
One half, sorry, negative one half. I wasn't doing all of it.
You're there, it's okay.
I did
So-
about half of it and stopped.
So you set this one up, does everybody agree you're going to subtract 1 and divide by 4?
Yeah.
So we have the cosine of x equals negative 2/4. So x is going to equal the inverse cosine of negative 1/2. So this means, again, where is your cosine going to be equal to a negative 1/2? It's got to be second quadrant because cosine is negative. So it's negative 1 and 2. What angle is that? 60. So the reference is 60. In the second quadrant coming up, it's what? Perfect. 2 pi over 3. Now, what other quadrant is cosine negative?
3.
Good. It's down here as well, so we have to add. We came up pi over 3, now we go down pi over 3, so you're at 4 pi. Those are your two values of x that make this a true statement within one revolution.
Yeah?
No, because if you look at the parameter, it's between 0 and 2 pi. Okay? Yeah, but yes, because we subtracted 1, so we had negative 2/4, so it's negative 1/2. Okay? We okay?
Yeah.
Was this too much to ask for after your brains are in park?
Yeah. Oh, I get it.
Okay? The square root of 3 times the tangent of x minus 1 is 0.
All right.
Subtle trick with this. Everybody's agreeing that you have to add 1 divided by root 3, correct?
Yeah.
Okay. And you're right. So you have the tangent value of x is 1 over root 3. Now, if I rewrote it as root 3 over 3, does that really matter?
Not really.
It doesn't really, because here's what happens. At this point, you're looking for the value of what angle has a tangent value of 1 over the square root of 3. You're not trying to rationalize the value, you're trying to find the angle.
Yes.
So in this case, it's positive, tangent, I'm in the first quadrant. My opposite is 1, my adjacent is root 3. What's my angle? 30, so it's pi over 6. So did I have to rewrite it as root 3 over 3 to solve that?
No.
Sometimes it's a little bit cleaner to not rationalize when you're solving equations because it's easier to place it into the triangle. Does that make sense?
Yeah.
It's a little subtle trick. So I know that this value is going to be at pi over 6. And where else is tangent positive?
3.
Third quadrant, so it is at
7 pi over 6.
it's magical.
I got this.
Remember, because your reference angle comes up pi over 6, and then the third quadrant's got to go down pi over 6. You're adding 1/6 to pi.
I know, but how did you know to find this 7 pi over 6 in the third quadrant?
Tangent's positive. Remember, tangent is opposite over adjacent. When you have opposite over adjacent and they're both negative, negative divided by negative is? There you go.
Okay, so if you're given a negative fraction, you multiply
Correct. Yeah.
because that,
Because if you're looking at the negative, when we did one a second ago, where it was negative 1/2, if it's cosine negative, that meant it went this direction, because cosine's negative in the second or the third. This is just a little subtle difference because I'm asking for it within that one revolution of theta, as opposed to what is the angle that has. So if you see this, then you're okay to go bouncing into all quadrants.
so what if it is 2 pi?
You're not going to include, because then if it's too high, it's also at 0.
Oh.
See what I'm saying? That's how it works. All right.
Is that tangent squared?
It is. This isn't the park test.
1.
So you have sine of x times tangent squared of x equals sine of x. Divide by what?
Sine of x.
Divide by sine of x. Good.
That gives you
So if you divide both sides by sine of x, you get tangent squared equals,
1.
okay,
And then you divide by 10.
then you square root that.
Oh, square root. Oh, okay.
Square root. So what happens when you take a square root over an equal?
You do it to the other side.
What was it?
Positive, negative.
Very good. So what happens is I'm going to take the square root of both sides, and I get the tangent of x equals plus or minus 1. So x would equal the inverse tangent of plus or minus 1. So this is asking me what angle or angles have a tangent of positive or negative 1. All of them. Which is that?
Okay, I would go to, I don't know.
What?
It's your 45.
Yeah, I think
Okay?
45 is
Now, everybody's okay that
What do you think you're on the?
it's going to be all of my pi over 4s. Why is that? Because at 45 degrees, it's 1 over 1, and then it's negative 1 over 1. Here is negative 1 over negative 1, and here is 1 over negative 1. So each of these 4 angles has a tangent value of either positive or negative 1. So it's in all 4 quadrants at
Pi over 4.
pi over 4.
5 pi over
3
4.
pi over
3 pi, you're right, 3 pi over 4, and then you have 5 pi over 4.
7 pi over 4.
Oh, sorry.
So there's 4 possible angles that would make this a true statement. That's all that is.
Sound good to me?
All right?
Okay.
Sounds like homework. Yes, yes, ma'am.
Would it be 90?
What's the tangent at 90? 1 over 0, so it's undefined. What's happening is that it's at all the pi over 4s, so you start here and you add 90 degrees, add 90 degrees, add 90 degrees. That's how that's happening. Because this is just a shifted. Okay. No, we're not doing those. Because I'm putting this together because I'm not doing, yes, sir.
So what again is going to be on the re-quiz tomorrow?
Well, the quiz is on the first time.
Okay, so it's just nothing new?
Hey,
Okay.
you're still doing, but you see how we're still finding angles here? That's why I
Yeah.
figured that this stuff isn't such a bad idea to kind of blend them together. What was the other one I wanted to look at? Try those two.
Good job, changed. I just mined my grade.
All right, let's say the first one's pretty easy. Subtract 4 divided by 2, you get cosine of a half. Do you agree? So x is going to equal the inverse cosine of a half.
Finally broke.
So what angle has the cosine of 1/2?
I don't know.
Pi over 3.
So you're 60 degree?
Yeah.
So 60 degree first quadrant. So it's pi over 3. Where else is cosine positive? 4th quadrant. So then I have to take 2 pi, subtract a third, and I get? See how easy that is? Okay. Other one. Move the 3 cosine x, and then add the root 3. So you get cosine of x will equal the root 3 over 2. We okay on that?
Yeah.
So what angle has a cosine value over 3 over 2. Your 30-degree does, so it's pi over 6, and then it's also in the second quadrant.
Fourth quadrant.
Oh, I'm sorry, I thought I said sine. Yeah, cosine, so it's a pi over 6 and then 11 pi over 6. Sorry, I thought for some reason I thought that was sine. Now, let me give you the one little twist that's different that can be between these types of problems. There's one very subtle difference that they'll give you.
I'm not really settled.
I was wondering why that was still on.
Now, instead of being within one revolution, I'm going to ask you to find what's called the general solution. When you find a general solution, the process to get to it doesn't change. It's your final result that changes. So in this one here, tangent squared of x equals cosine of x times tangent squared of x. What do you think you're going to do first?
Divide by tan.
You divide both sides by tangent squared, and you get cosine of x is equal to 1. So let's see, cosine of x equals 1. So what angle has a cosine value
90.
of 1?
90.
Yeah, right there.
No.
No, but it's so. Oh, I was supposed to cause cosine.
Wait. 0.
Is there any other values that has a cosine of 1?
No.
No. So your answer here is at 0. Now, is 0 degree or 0 radians?
Yes.
Yes, that's the correct answer. It's both. Okay. Now, what a general solution means is how much pi does it take to get back to it?
2 pi.
In this problem, there's only one answer. 0. Okay? Because it's the only place that cosine is equal to 1. As I'm going around my circle, I get back to 0 when I add 2 pi to it. Now, does it matter how many times I go around? I'm still going to wind up that same spot.
Yeah.
So no matter if I go around 4 times, I'm there. 5 times, 6. So what we do is say 2 pi n for the number of times you go around.
Wait, so then would our answer be 0 plus 2 pi n?
That's exactly it. The difference here between a bounded solution, which is within one revolution between 0 and 2 pi, that means just list all the possible angles you can get. The general solution is, how generic can you make it? Well, my cosine is going to be 1 every time I get to 0, every time I go around the circle. It's going to be 1 when I get there. Okay? It's a little bit different when you have values that aren't 1. Excuse me. For example, let's do.
So we can apply to any of them.
Yes. 21.
Then there's an element.
If I want to go back to the real easy one, 2 cosine of x minus 1 is 0. Then I'm going to do the general solution again, because it doesn't say within 1. Okay. If I do general solution here, everybody's okay. We've done this one earlier. It was you add 1 divided by 2, you have cosine of x is a half. Okay. So the angles that wound up with a cosine value equal to a half, to be positive, were in the first and in the fourth quadrant, correct?
Yeah.
It was 6 pi over 6 and 11 pi over 6? Because this is our, somebody know how to draw it. Oh, sorry, yeah, it's our 30 degree, because this, our opposite is,
It's cosine.
So,
yeah, it was pi, it was 60, so it was pi over 3.
Well, we took this before, but it was sign.
Oh, that's what it was. I wasn't sure if it was sine or cosine. So it was at pi over 3, and then the other one would be at 5 pi over 3. Now, just to show you placement, pi over 3, 5 pi over 3. If I want to, how long does it take me to get from here to here? So it's going to be pi over 3 plus 2 pi n. You okay on that? How long does it take me to get from 5 pi over 3 back to?
so that's 2 pi.
Yep.
If
So is it
it,
always 2 pi?
if it was tan, would it be just pi?
Correct.
Okay.
And that's little subtleties. If you wind up with a tangent value, tangent's positive diagonal from one another. Right? So your tangent was here, you add pi, you get here, you add pi, you get here, you add pi, you get here. So you just have to, you'll start to see it. Okay? The general solution is usually what takes the longest to comprehend how you write it out. The solving of the equations is a piece of cake. That's easy. Okay? And this is something new that I've never done in this sequence. I've never taught this section after spending all that time working with inverses. Why, I don't know. But this is the application of doing inverses. Before, we would wait like 3 weeks and then we would do this again. And you guys have to go, what does that mean again? Which means you should do well at these things. Okay? I'm going to give you a couple of these to try out.
Said about the parts.
So something means 1 or 2, right?
Jill, can I get another piece of paper? One for me and one for everyone. Yes.
Austin.
Do you like your book?
I think I've got, what, 6 of these for you? These are all within 1 revolution problems. We'll just do 1 revolution stuff for tonight. We'll do our re-quiz stuff tomorrow. We'll revisit this Friday with more of the general stuff, and then we'll go from there. Okay? Questions?
Can you pull up
Can I use your book? Yeah, that's what I need.
Well, check if you're looking up in the website.
What? Oh, yourself.
what's up, bro?
Well, chapter 14 up in the website.
Yeah, it's already up. I put it up there this morning.
Picture that whole thing.
Ah.
Thank you.
Here's it.
I'll just throw them in here so you guys can.
I know. Is that stuff?
Oh,
So you can blow it up.
Oh, but it's a traitor. Oh, it's a traitor.
What's up?
Oh, I'm a traitor.
Hey.
I hope.